Now let's run the same exact code generation task, but this time with Sonar Context Augmentation. After a simple JSON configuration, we launch Claude Code, which automatically detects and launches the SonarQube MCP server. We then execute our code generation task once again. This time, however, the LLM receives crucial information, the project guidelines, the current architecture, and the intended architecture. The current architecture provides an LLM with a comprehensive understanding of the repository high-level structure, and the intended architecture establishes strict constraints for the agents to follow, as we are gonna see in a second, specifically enforcing the data flow from the controller to the service and down to the DynamoDB package that contains the repository. The LLM gets a high-level view of the structure of the repository and receives specific coding guidelines, including the highlighted Java rule about logging injection that will be important later on in the video. After an initial exploration phase, the LLM begins implementing the task. Guided by our architectural constraints, it now writes the code correctly. The controller defines a new service specifically for the research organization usage feature and references that service in full compliance with the intended architecture. Now, following this, the LLM pushes the code and open a pull request, as in the previous example. As we review the result, we will be able to see that the continuous integration job will no longer detect any architectural violation, entirely because the intended boundaries were respected. However, there is still a catch. A log injection vulnerability remains present in the code. Even when provided strict guidelines, the LLM might overlook them if they lack sufficient context or if they involve complex flow-related rules. And this highlights a critical need in our workflow. Right after the code generation phase, we must provide the LLM with a dedicated tool to independently verify its newly generated code without relying on the external CI pipeline. This keeps the agent within the fast inner loop of the agent-centric development cycle.